Hi grade 7s, welcome back to another one of our video lessons. So today we're going to continue on page 100 and we'll look at multiplying decimal fractions by decimal fractions. Okay, so remember in our previous few lessons we talked about decimal fractions, how do we get them, how do we convert them from common fractions. Then we looked about how do we multiply a whole number by a decimal fraction. And remember, all we did was we dropped the decimal points, we counted how many places there were, we multiplied the two numbers, and then we added the decimal place into the, well, how many we had from before. Okay. Then we talked about dividing by a decimal fraction, which is the same thing. We divide by the number, take away the decimals, and then add them back to the answer. Okay, so now the last step is multiplying decimal fraction by decimal fraction. I even remember in my last lesson, I even introduced that to you. We did 0.2 times 0.3, and we worked that out. All right, so the idea here is exactly the same. We're taking the decimals away from both numbers and we're adding the combination of them. All right, so I'll explain what I mean. So let's do our examples on page 100. I worked examples. So it says calculate 0.2 times 1.4. Okay, so we have 0.2 times 1.4. Both of these are decimal fractions. So what are we going to do? Well, remember, we drop the decimal points, okay, or the decimal places. So here we have one, here we have another one. So that's two decimal places that we're going to remember for later. Okay, now we drop the zeros and the decimal. The number that I have left here is a 2. I drop the decimal point. The number that I have here is 14. So we're going to multiply 14 by 2, and we're going to get, so 14 times 2 is 8, and 2, which is 28. Okay, so we're going to put the 28 there. But now, before we finish, we need to add the decimal places here that we took away. So here we have one decimal place, another decimal place. So we need to add two decimal places into this equation. All right. So here the decimal usually goes after the last number. So we bring it back 1, 2. So the comma goes here and the answer is 0.28, not 28. Okay. So again, drop the decimal, count how many places we have. Remember that. Multiply the numbers, get your answer, and then add the required number of decimal places. Okay. Right, let's do the next example. So the next example says 2.34 times 0.7. So 2.34 times 0.7. Okay. So we're dropping the decimal. We have two places here. We have another place there. So 3 in total that we're going to remember. Now we drop the commas. We look at the numbers. So we have 234 multiplied by 7. Okay. 7 times 4 is 28. Carry the 2. 7 times 3 is 21. Plus 2 is 23. Carry the 2. 7 times 2 is 14. Plus 2 is 16. So the answer that we get is 1638. But remember, we need to add the decimal commas. Now, remember from the previous example, what we said is that estimate your answer first before you multiply so that you have an idea of what your answer should look like. So if we look at this 2.34, well, this is close to maybe 2.5. 2.5 times 0.7, 0.7 is close to 1. So my answer that I get should be around maybe 2.5, but a lot less because we rounded this up to 1, but we only have 0.7. So the point that I'm saying is that the answer should be less than 2, okay, but not a 10 or 100 or 1,000 or anything like that. So here, looking at this answer, I know that this can't be the answer. It needs to be a lot smaller, so I'm going to say 1638. Now I'm going to add the decimal points, 1, 2, 3 places. So 1, 2, 3, the comma goes there. The answer that we get is 1.638. Is that in line with our estimation? Yes, because we said it should be less than 2. Okay. Right, guys, so that's how you can check yourself if you're on the right track or if you got the answer correct. Okay. Right, so now what we were going to look at is exercise 7.9. So 7.9, questions 1 to 6 is just your simple multiplication like we did on the board. Number 7, 8, and 9 are a little bit harder because they give you a word problem that you need to now solve. So let's quickly run through them and I'll explain what you need to do, and you guys are going to do them for homework. Right, number 7. A supermarket sells chicken at 21 Rand, 99 Rand per kilo. A customer buys 3 different packets with masses of 1.871 kg, 2.110 kg, and 1.945 kg. What is the total cost of this purchase? Round the number to 2 decimal places. Okay, so firstly, we have these chickens that we are buying that are different weight. Okay, and we are also given a per kilo price. Now remember, when you get to the shop, if let's say you have 2 pieces of chicken that are for sale, right, and one is more expensive than the other, but they have different weights, how are you going to determine which one's more expensive and which one is cheaper? Remember, even with fractions, if I give you 2 fractions and I say which one's bigger or larger, you can't straight away tell me because we need to have a common denominator to compare it to. So the same thing with food. Whenever you're buying something that is given a per kilo price, that is them trying to make it easy for you so that you can compare price, because they'll quote you how much a kilo of this chicken costs. Let's say it's 50 Rand. And another chicken is double the price. It costs 100 Rand a kilo. Okay, so it's the same kilo of meat, maybe different quality chicken, but one is 50, one is 100. So then whatever quantity of chicken I get of either one, I can determine the difference in price on the per kilo price, not on the actual quoted price on the pack. Okay. Right, so for number 7, we add all the chickens together. That's what you're going to do first, and then you're going to multiply by the price of chicken, and we're rounding off to 2 decimal places. Why? Because remember, we are dealing with money. We are dealing with cents. I cannot pay half a cent at the till. Okay. Right, so that's number 7. Number 8, the price of diesel per liter is 11 Rand 43. Minky's bucket took 40 liters, 40.25 liters. What is the total cost of diesel? Round the total to 1 decimal place. Okay, so here they're telling you how many liters are bought. What is the price per liter? Obviously, you have to multiply the two together and round off your place, round your answer to 1 decimal place. Okay. Number 9, Max's monthly electrical budget only allows him to use 250.5 kilowatt hours. The cost for 1 kilowatt is 2 Rand 20. Calculate the cost of his electricity bill. Okay, again, they give you a cost of 1 kilowatt. They tell you that his total consumption is 250. So what is his total cost? Okay, so you guys have to remember to round off his answer to always 2 decimal places, unless I state otherwise, or the question says no, do it to 1, or no, do it to 3, or whatever it is. But the general rule is that when we're dealing with money, it's always 2 decimal places. Okay. Right, guys, so I want you to look at exercise 7.9, do that, and I want you to do the revision section at the end of this chapter, which is on page 101. Cool, guys, let's now continue. We're going to now start our functions and relations. All right. So I'm going to start reading from the top on page 104. You guys can follow me, and I'll explain as I go along. So by using a description or a rule, you'll be able to describe a relationship between numbers. A number sentence is a useful way to write a rule and solve problems. Okay. Recognition of variables, constants, and coefficients. Okay, so we're going to first define what these things are, and I'll explain how they work, and then we'll apply them to solving problems. So a constant is something that never changes. So a constant is a number. Okay, so like a number 5. A 5 cannot be any other number. A number 5 is a number 5, so it's a constant. Okay, so a constant is something that never changes. For example, the number of sides in a triangle, which is 3. A variable is something that can change in value. For example, the daily temperature. Okay, so I'll say the daily temperature is T. Okay, it's a variable T. What is the value of that variable T? Well, it depends on what day we are looking on. Today it could be 20 degrees. Tomorrow it could be 22 degrees. So the value T is a variable that it represents today's temperature, and it can take on different values depending on what the situation is. Okay, but a number 5 cannot take on different values on different days. No, number 5 is a number 5 and that's it. Okay. So a coefficient is a number with which the variable has been multiplied. Okay, so the coefficient is always the number in front of the variable. And remember, the sign belongs to that number. So if I have minus 2x, minus 2 is the coefficient, x is the variable. Remember, variables are usually letters. Okay, so if you see a letter, it's a variable. If you see a number, it could either be a constant or a coefficient. If it's a coefficient, it's in front of the variable. All right. Okay, so let me read that again. Coefficient is a number with which the variable has been multiplied. For example, the perimeter of a square equals P equals to 4 length. Okay, now let's quickly look at that. Okay, so I know my perimeter of a square is 4 times the length. Length is the size of one of these sides. Remember, all these sides of a square are all the same. So if one of them is length, then the perimeter is 4 times that length. Okay, so this is an algebraic equation. It has two variables, perimeter and length, which can take on certain values. Okay, and 4 is in front of the length, which means this is a coefficient. Okay, so now I could think of a square. Let's say in this room there's a box and the sides are 20 centimeters each. Okay, so for my box I can apply those values and say, well, what is the perimeter if length equals 20 centimeters? Well, it's going to be 44 times 20 centimeters equals to 80 centimeters. Okay, but if you're sitting at home and you have a different square, let's say your square is 1 meter, which is the sides, then you'll say, right, well, the perimeter of my box at home is 4 times 1 meter, which is 4 meters. Okay, but mine is only 80 centimeters. Okay, so what I'm trying to demonstrate here is that the rule or the equation here tells us the basic relationship between the two variables. What values do those variables take on? Well, that's up to us to determine. Okay, we could say the length could be 5 meters or 10 meters or 100 meters or whatever it is. Okay, it doesn't matter what the length is. The point is that the perimeter will always be 4 times that length. Okay, guys, and that's how we're going to be using equations to solve for unknowns or to find interesting things. Okay. Right, now let's continue. I want to tell you about a difference between an algebraic expression and an algebraic equation. Okay, and the difference is very easy, is that one has an equal signs and the other one doesn't have an equal sign. Okay, so obviously algebraic equation has an equal sign. Okay, so if I write something like 3x plus 5, that is just an algebraic expression. Okay, so this could be just, I don't know, I got 3 packs of marbles, which have 5 marbles in each, plus I have 5 already at home. Okay, so I'm just counting something up, and I'll say it equals to whatever. But the point is that the way it's written, this is an algebraic expression. Okay. Now, the terms in algebraic expressions or equation are separated by plus and a minus. So if we look here, this has 2 terms because it is separated by a plus. Okay. Now, if I say 3x plus 5 equals to 2, now that is an algebraic equation. Why? Well, because there's only one value of x that will make this true. Okay, so this equation will enable us to find the unknown. Okay, and I'll show you as we move through the section, I'll show you how we do that. Okay, so again, an algebraic equation has an equal sign. An algebraic expression does not have an equal sign. Okay, So in our book, we have a few examples of them. And if we look at algebraic equations, we have an example that I want to quickly do. So the algebraic equation says 7 plus 3x equals 2y plus 5. Okay, so that is an equation that they've given us. And they say if x equals to 2, y equals to 4, then this will hold true. Well, let's try it out. So they say x equals to 2 and y equals to 4. Okay, well, let's see if now the left-hand side will equal to the right-hand side with those particular values. Okay, so we have 7 plus 3x, x is 2, which is 6, which equals to 13. Okay, this side, 2 times y, 2 times 4 is 8. 8 plus 5 equals to 13. Okay, do you see that both sides are the same? So these values of x and y make this equation true. Okay, maybe there are other values of x and y that can make this equation true, but at this stage we're not really concerned with that. The point is that the equal sign means that whatever we have on the left-hand side equals to whatever we have on the right-hand side. And we've proved that by substituting our values in. Alright guys, so that is our equations and expressions. So now if we look at 8.1, number 1 says, are the following examples of variables or constants? Okay, so think about it, right? Is it a constant? Is it a variable? So can that thing change, or is that thing fixed and that is it? Okay, so let's look at the examples. 1a, the number of hours in a day. Okay, the number of hours in a day is 24. Can we have a particular day, say tomorrow, where we could have 22 hours and then 26 hours? No. We work on a calendar and a clock, and it's been said that there are 24 hours in a day. Okay, we're not going to talk about physics and science saying that the world is slowing down or moving away from the center and the days are actually getting longer by like 4 minutes every year or 4 seconds or whatever that is. That's not what we're talking about. The convention is that there are 24 hours in a day, and that's that. Okay, so that is a constant. 1b, the number of hours of daylight in a day. Okay, so now this is different. How many hours of daylight we have depends on the seasons, okay? And the seasons are obviously governed by the way the earth works and moves and so on. So is this a variable or is this a constant? Can the number of the hours in a day of sunlight change from day to day? Yes, because we know in winter sun rises a lot later and goes down a lot earlier. So we obviously have less numbers of sunlight. And in summer, it's the opposite. So B would be a variable. C, the number of sides in a pentagon. Okay, well, a pentagon is defined as a shape with 5 sides. So if we have a pentagon, can it have any other number of sides than 5? No, which means that it's a constant. D, the perimeter of pentagons. Okay, the perimeter of pentagons. Well, we know that a pentagon has 5 sides. Okay, now it's a hexagon. Okay, let's say there's a skew pentagon like that. It has 5 sides, but can we have different pentagons? Of course, right? I could have a smaller one just inside it, or I could have a bigger one just outside it, or I could have whatever size pentagon I want. So obviously the perimeter will depend on how big the sides are. So that would be a variable. All right, guys, so what I want you to do is work through exercise 8.1, and I will continue with you with the next worked example, and we'll do 8.2 and 8.3. So for today, I want you to do exercise. So from before, we had 7.9. You have the revision to do for this week. You can start today, but make sure it's done by the end of the week. And I want you to do exercise 8.1. Okay, guys, thank you very much. I hope you enjoyed the lesson. I was hoping to see everyone at school today, but it's not happening. So I'll hopefully see you next week. Okay, guys, take it easy, and I'll see you next time.